Hi, I welcome you to Remedial One YouTube channel. Today we are going to look at how we can able to apply the first principles of derivatives to differentiate. We are looking at 2021. For you to really do well when it comes to using the first principle, which is kind of is a definition that have been given, you need to know two components. You need to know how you can able to apply the Pascal's principle to expand, because you have to really move a little faster, and you have to know your binomial expansion too. I have done a video on this binomial and Pascal, so I will attach it to this, but as I'm going along I will be explaining some of the stuff, so I believe that will be also helpful. So let's go ahead and solve this one. So we have been given y is equals to into bracket 3x to the power 4 plus x cubed bracket close times x to the power negative 1. So the reason why here they are saying that x is not equal to 0, you gotta know this. X to the power negative 1 is the same as 1 over x. So that's the reason why. So they are saying that this x here not supposed to be equal to 0, because if it is equal to 0, it's not defined. With that said, so that means we can say that the y must be equals to, and this here we can write it as such. So times 1 over x. So we can remove the bracket and then we can get 3x 4 divided by x and then plus x cubed all on x, which we have x is common on both sides of it, so it can be reduced because we have x here. So you take this one and then you reduce it to x cubed, and here x is common, so you reduce, you take 1 here and that become x squared. So we are going to apply the first principle, and the first principle is a definition. You need to know that, which is stated that the limit as h approaches 0 is f of x plus h minus f of x all divided by h. So this is the definition, and they want you to apply this definition to solve this question. Remember, this is 2011 Wassce theory question, and as I was talking about, we have a cube here and we have a square, so you need to know your Pascal's. Pascal's is like this, and you're starting with 1 and then we get 1 2 1. So this is like, this one is 1 degree and this one is 2nd degree, and the 3rd degree to the power cube, which is, we got 1 and you add this, you get 3 and you get 3 and you get 1. So these are the coefficients. The Pascals help you with the coefficients, and then yes, so as we are moving along, watch the video and then you will get that. So we need to know that so that it will help us to expand this kind of stuff really quick, because we are using the definition. So here I'm going to say let f of x equals to this y here, which is the same as that. And then I need my f of x plus h. So in this here, wherever I see x, I'm going to replace it with x plus h. So here I get 3 into bracket x plus h all cubed, and here x plus h all squared. And I need to expand this one. That's the reason why I need these coefficients. So let's go ahead and expand this, and then we will bring it back into the formula. Expanding here, I have my 3 here, and this one, since it's a cube, we are going to use this 3rd power here. So the first one will take all of it. So here will be x to the power 3. The second one is going to be 3. So it's going to be 3. And then I will reduce this one by 1, which is going to be 2. And this one will pick up from here. Plus another 3. And this is going to be reduced. This will pick it up. And finally, plus the h will take all of it. Plus this one is squared, so we are using this coefficient 1 to 1. So here is going to be x squared plus 2xh plus h squared. And then here you have a coefficient, so we're going to multiply to each of them, and that will give us our f of x. So this time this will be 3x cubed. 3 times 3, 9, so 9x squared h plus 9xh squared plus 3h cubed plus, removing the bracket, squared 2sh plus h squared. Awesome. So we have made a lot of headway. What we are going to do is that we have expanded it, so the work is almost done. So we are going to use our first derivative formula, which is this, which says that the limit as h tending to 0, f of x plus h, which we got it to be longer here, minus f of x, which is here. So we're going to put it in there. So we'll write the cube plus, let's use our brackets open here. Basically you're rewriting this minus f of x, which is this one, all divided by h. Then this is equals to the lim of h turning into 0. When we remove the bracket, we see that this will subtract this away and this will take away this. So we got 9x squared h plus 9x h squared plus 3h cubed plus 2x h plus h squared, all on h. But this h will reduce this, take this one away. It will reduce this one to 1. It will reduce this one to 2. It will take this one away. It will reduce this one to 1. The limit as h turned into 0, we got 9x squared plus 9xh plus 3h squared plus 2x plus h. But now we are going to substitute. The h is turning into 0, so as h turn into 0, we are getting 9x squared plus 9 times 0, because here is going to be that. The h is turning into 0, and here 0 squared plus 2x plus 0. And that is going to give us, this one will go away, turn into 0, already 0. So we got 9x squared plus 2x. And that we are done. So we have able to apply the first principle to differentiate that given equation. So right from the beginning, even you could have differentiate with the simple formula that you know, and then you see the answer and then you work towards it. But here they wanted us to apply the definition to get it done. Okay, so let's look at one more question that also came in 2018. which is going to be easy peasy because it's really small as compared to the first one. So here you let f of x equals to y, which is equals to this plus 1. If that is the case, we are applying the first principle, which says that the limit as h tending to 0, f of x plus h minus f of x all on h. So we need our f of x plus h. So f of x plus h. Wherever we see x, we are just going to replace it with that. And we bring our square and then plus 1. And now we need to expand this using the Pascals, which is going to be the coefficient is 1, 1, 2, 1. So here to pick all of it, here to multiply all of this, so 2xh, and then the h will pick the last of it, okay? And then it's plus 1. Or if you want, you can write x plus h into bracket and then times another x plus h, and then you do your expansion over there too. That one is also acceptable. But I was looking at the situation whereby you can move really quick, and that is where the Pascal's expansion comes in. Okay, so you see this one is much easier. We are almost done. So here, as we are finding our first derivative, the first differential as the lim of h tending to 0, we got our f of x plus h to be x squared plus 2xh plus h squared plus 1 minus the f of x, which is the same as x squared plus 1 all on h. So here we can do our cross out this, take this away, this, take that away, and then as the limit as h tending to 0, we got 2xh plus h squared all on h. So here h, take h away, h reduce it into 1, so we got f of first derivative of f of x, which is equals to the limit as h tending to 0 of 2x plus h. While we know that the h is turning into 0, so here becomes 0, and then finally we got 2x as a final answer. Awesome. Thank you very much for watching, for sticking with me all the way to the end. So in our next video, we're going to do part 2 of this. We are going to look at the rational equation using the first derivative, and we will touch more also into the binomial expansion. And about that time, you'll be ready, set, go to go get your A1 in Wassce, elective mathematics. Be blessed. Bye-bye.